Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at using radians to calculate the arc length and the area of a sector. So if you've forgotten, arc is part of a circumference here around the outside of this circle, and sector is part of a circle. A sector is like a slice of pie taken from a circle. This thing shaded yellow is a sector. So we call this angle here the angle subtended by this arc. I'll call it theta. Now, the arc length is just radius times theta, and the area of the sector is just half r squared theta, as long as theta is in radians. So let's look at this question here. Theta is not in radians, so the first thing I need to do is convert it to radians. So remember, to go from degrees to radians, you multiply by pi over 180. So 30 degrees is pi on 6 radians. So here, this arc length here, L, is just going to be radius times angle in radians, and you can put that in your calculator. You get about 6.28 centimeters. So the area of this whole sector here, once again, we need to use theta in radians. It will be a half times radius squared times, again, angle in radians. And putting that in our calculator, we get 37.7. Of course, area is in square units, so it'll be centimeters squared. And then we're done. All right, let's look at a slightly harder question. So for this question, I need to find L, this arc length here. I can't find L unless I know the radius. So what I'm going to need to do is take that the area of this sector is 60 centimeters squared and use it to find the radius. So I know the area of any sector is a half r squared theta. So here A is 60 and I need to find r. Now I can't put 100 for theta because theta has to be in radians. So I need to convert 100 degrees to radians. So I go 100 times pi over 180 gives me 5 pi on 9 radians. Now I'm going to solve for r. So I multiply both sides by 2. That's how I got the 120, got rid of the half, and then I divide each side by 5 pi on 9. So that will give me r squared, and then I just need to square root both sides, and that will give me r. So putting that in my calculator, I get that the radius is about 8.292. So now I can easily find the arc length. It will just be the radius times theta. Once again, theta must be in radians. So putting that in the calculator, I get about 14.5, and because the area was centimeters squared, it'll be 14.5 centimeters. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.